Hello everyone and welcome back. So in this video we'll continue on the series of creating this chocolate split. So here's some render I did of the current progress of the project, and hopefully you'll get something similar at the end. But I've got some bad news. This network got a bit bigger, so we still have a lot of ground to cover. So let's get back to our initial scene and start working on the next step. So here we are where we left off. We got some basic UVs and all the shapes ready, but we will have to take a step back because I want to change some of the things. First of all, this pattern of the break is a bit boring, so I want to increase a bit the roughness and the repetition of the noise. So we will drag this down and go back before this boolean, and we will change some of the settings of the noise for the breaking. But before that, let's actually create some groups in here. So for this, we will make a group and call it chocobar exterior. We'll copy this and paste this one in here for the interior. And now for the noise. First of all, we will move this subdivision above. And let's see, let's set it to 3 in this case. And for the noise, we're still gonna do noise along vector, but we will decrease the amplitude to 0.03 and change the element size so to 0.08. And I have in here an offset that I played with that I like, so something like this. Let's see now the boolean, and it will be hard to see. We need to calculate the connectivity that in this case we will set to primitive, so that was a change I made. And as you can see, the pattern now looks a bit more interesting. So in this case, we're getting a lot of divisions. Maybe we can go back a bit where we did this exocyte quad remesher, and maybe we can unlock it and set it to 650. I've been getting this error with the quad remesher, I don't know why. So after the smoothing and set initial point, I guess this will be fine. So let's lock it and let's compute everything again. Oops. And we still have to do the wrinkle deformer and whatnot. So let's see. Yeah, I guess this will be more like it. We still have a lot of divisions, but it's a bit lower poly on the inside. So I guess that's fine. So first of all, let's move all of these out from here. So let's pick this and press Y. And we will come back to this a bit later. So shift and drag to the side. And now we have these two shapes. And the thing is, I want to create some, let me pause in here, some interior detail. And for that, we will need proper UVs and proper edge flow to create some straight UVs. So we can't work really with this geometry that we have right now. So for that, I'm gonna split in here and make sure I have saved the B inside B, how is it called? B inside A, let's see that group. So B inside A, yeah, that's it. So if we now come in here and split, paste on the B inside A, we will have these two shapes that if we explode, and in this case we need to set this to primitive, it won't work very well. So let's connect this in here. And we have two shapes on top of each other. If I can show you, as you can see, we have primitives on top of each other. And we could, let me get rid of this. We could try the exploded view in here, as I just did, but I couldn't get it to work because we need to take these apart somehow. So we're going to do a custom exploded view in this case. And it will be easier if we do it based on packed primitives. That way we only have 2 points to work with. So let's do that. Let's create first a null in here and another one in here, because this is the rest of our geometry that we need to merge over. So let's do a pack based on the class attribute. So let's do class, and we have 2 points, 2 prims, that's fine. And now we can do a custom exploded view. And this will be explode Z. And this will be pretty simple. So we first have to identify, we have to create a sign to offset them along the Z. In this case, they are oriented towards the Zs. So for that, I'm going to create a float sign, and it will be equal to the ptnum. So we just have 0 and 1, and I want between -1 and 1, so multiply by 2 minus 1.0. And now we simply do v plus equal, and we will set 0.0 along the x, 0.0 along the y, and the sign along the z. Let's see that. And we should have them apart. But I want to control, so float the times channel float and amplitude slider. So amp, or we can call it this. And now we can control how they are apart from each other. So I'm gonna set this to 0.1, that's fine. And now we can unpack this and try to work on our geometry. So if we unpack, and I'm not sure if I need to, I don't need to promote any attributes. So let's set this to flat so we can see it a little bit better. And now we can do a exoside quad remesher. We can try to do one. Let's set it to 500. And let's see the result. As you can see, we will have this kind of thing. And this will be, I tried many ways to make this work, but I couldn't get it to have really the flow of the edges to be perfect. So this will be a problem when we try to create straight UVs. So with the rectify command in the option in the UV flatten. So unfortunately, and we still have some issues, you can see this won't work. I wish this would work because we have to take a big detour to make it a perfect topology. But you know, it will be a learning experience. So let's get rid of this and create in here. Let's see where this goes. We will first create an unshared group. So this is labs unshared, and we'll select edges and then convert line. And this will be like this. Now we will split this based on the primnum. So we'll set this to primitives. It is by default primitives, but anyways, we'll set all every other one. So, and we get, in this case, the outside ones, as you can see. All right, I believe that's what I got in here. Yeah. Then we have the outside in here and the inside in here. Then simply we can do a resample. Let me see how much did I use. So, so I used, sorry, let me see that again, 0.02. So not too much. So 0.02, and we have this amount of points. And it's all well spread out. So 0.02. Now we can do the following in here. We can take this geometry and mean pose it to the target geometry, which is the inside. We basically creating the paving the way for a perfect topology. So let's do v at p. It will be equal to mean pose. This is the minimum position command on the ray node, so you can even use the ray node. Mean pose of the current position. So let's see how that goes. And we get this. It will constrain to the inside parts. Now we can merge this. And we have the following. As you can see now, the topology, it will be a bit better. And now we can just skin this. So first of all, let's fuse, because we have some open points from the resample. And now we can do a skin. And right away, let's plug in a normal, because I don't know why, but the skin messes up the normals. As you, in this, yeah, it messes, as you can see. But let's see. Let's go into the skin, and we will skip every other primitive. And as you can see, now we have this almost perfect topology. And if we do, let's say, subdivide, we will have these edges flowing in the middle, as you can see. And this will be perfect to cut out every other every end edge, This way we will have different strips and we can have an high resolution texture in there that we will do it with cops. So we can get rid of this subdivide for now, and we also might need to reverse this because let's see. I need to enable this. So let me see in here. In this case, is correct. So let's see. Yeah, in this case, it's facing the correct direction. So let's see. Do we need to fuse these maybe? Let's see if that makes a difference. Yeah, it does because we have open points in there, as you can see. Hopefully, you can see it in the recording. All right. Now we need to pay attention to something because right now if we have these over our chocolate bar, these edges won't align, and then at the render we will have a problem of the edges not aligning to the geometry, to the final geometry. So we need to reproject them somehow to the original geometry. But easier said than done, because you can try with the min pose and reproject it and whatnot, but it will never align perfectly because the topology is so different. So what we can do, as you can see, we have points all over the place. So I found a solution that works pretty well, and that includes doing first of all a reproject to the original geometry, so of this unpack. And I believe I need to do an unshared in here and set it to points, in this case edges, because I will need it for later. And now we will do a reproject to this, which is just the original geometry, as you can see. So the topology that we had previously. And if we do a reproject, we will have something like this. So what we can do is do it based on, let's see, vector, and Control Shift click and set this to 1. And we also need to enable max distance and set it to 0.1. So as you can see, it's reprojecting to the surface, but is not enough because we need to subdivide and reproject it again. So we will need to place another ray in here. So what we can do is create a feedback loop. So feedback. Let's change the color just to have a different color in here, and we will connect these in here and these in here. And in this case, I'm gonna set the amount to be around 4. 4 will be enough, and this will run pretty quickly. So as you can see, while he's subdividing, he's also reprojecting over and over. So in this case, 4 times. So that's fine, but we still have a very different edge, how do I say it? Edge match, let's say. So we need to take these unshared points and project them to the surface. And as you can see, the ray won't work very well. You can try the min pose, but that won't also work. So let's do the following. Let's do unshared and select the point. And now we can try again reproject and connect this to here. And make sure we do, let's see, minimum distance. And we need to select the group to be the unshared. And we might also need to convert this to line. So let's do the following. Let's grab the unshared in here. So let's do this. Let's create a line in here, and let's grab in here the unshared and do a convert line. Sorry. And let's do unshared, connect path, and we also need a resample and a fuse. So we will do one I resample and resampled by polygon edge, so around 0.005. And let's do a fuse also. So let's get rid of this visualization, and if we do the reproject to this minimum distance, let's see how that goes. It's not going to be bad, but it's not perfect either. So I'm trying to find in here as you can see in here. Do you see this? And it will bend and make it not work very well. Oh, you can see it clearly here. We can subdivide even more the geometry, but we'll never reach this edge that you can see in here. So I'm gonna attempt something that worked in my original scene, but I'm not sure it's going to work now, but we will try. So let's get rid of this ray and do instead a point relax. And we will take advantage of this point relax heavily in this project. So let's get rid of this and do 0.1 and connect this in here, and we will only select the unshared. And it won't be perfect, as you can see. So let me see something. So there are still some cases where this won't work as good, but it's a better solution than the min pause in this case. So this point relax will be important in our scene. So let's actually see something. If we do the same in here, so if we pack and explode it, let's say pack and explode it, and in this case we need to negate it. Let's see, yeah. So let's unpack also and visualize it, and let's see this. So as you can see, it will line up for the most part, and that's what we care about. As you can see in here, we have this problem. Oh, but we have some problem from the previous peak that we did. So we can actually go back where we do that peak. So after this, now let's see that peak, and that's smooth. And as you can see in here, we can reduce this to 0.04 maybe, and that will be a bit better, I guess. So let's go back in here, visualize this, so W, and visualize this. Still not perfect, but it's better than what we had. So if I find a better solution, I will let you know along the series, but for now we will go with this. So now we need to create UVs for this part, and we will do that in the next part. Okay guys, I forgot to do something in here. In this ray we want to set it not to forward only, but also to bidirectional, so it does on both sides. This won't fix some of our issues, but it will align better the geometry. So let's just check in here. Yeah, it's pretty much aligned. Then we can do a fuse or something like that to work on that part. But for the most part, and with the displacement and whatnot, we won't notice the gaps. But in the end, it's better than what we had. So we have now this perfect topology that we can work with. So let's leave this here, although we won't use it. And now, sorry, we have this geometry apart and we need to get back to the original position. So let's do the following. Let's create a connectivity on the prims, I believe. Yeah. So let's create a connectivity on the primitive and let's do a pack. And we will pack based on the class. Okay, Houdini being Houdini. Let's transfer the class. And now we want to transform this back. So for that, we're going to this in here and create a null. And we have this packed in here, so we can do the following. So let's get rid of this. Let's create a wrangle and get the pack transform. So we will get the transformation that we did on pack prims. So I'm gonna save it as a 4x4 matrix. So mtx, we will cast it as a matrix form and get packed transform 0, and we can do ptnum or primnum. I believe that's all. And now we can do the reset. So after this pack, we can create a wrangle and connect this geometry in here and this one in here, the pack transform. And let's create a variable in here to read in the matrix, which will be, we can just take as op input 1 MTX, because we have the same amount of points, so 2 on each side. And now let's do VHP times equal invert of the MTX. But as you can see, this will go to the center, so we need to do another step, which is VHP plus equal get bounding box center and incoming geometry. And now if we look at this and we do an unpack and we look at the original position, it's in the same position, but now with perfect topology. All right, now we need to take care of the UVs. So let's do a split. And for the UVs, it will be some simple solution, and we will do primitives at class is equal to 0 to get the first one, and we do a null in here and another one in there. So that's fine. This is the left one, this is the right one. And we will do the following. We will create first a group of the unshared points. So points, points, include by edges, unshared, and we will create these create boundary groups. That's fine. Now, we will create, we will have now two groups for the unshared, the inside one and the outside one. And we will do a group by range. And let's see. Let's select first of all these 2 points and go with, I believe it's the 0. Yeah. And let me see, unshared 0. And now we will do 1 out of n points group. So in that point group, we'll do 0. And let's actually name these to unshared. Oops, unshared. And let's do unshared 0, unshared 0. And we will do unshared underscore underscore 0. And we want to divide it, let's say, by 5. So we get like something like this. Let's see. In this case, I'm going to set it to 8. So divide it by 8. And now we can just use group find paths and promote it to edges. So group find path. And we will take the unshared 0 and unshared 0. And we will do loops or rings and extend to edge. And make sure we have in here a collision group that is the unshared 0. And make sure you set it to points. And now is not working. Okay, great. I have a different result. Why is that? So loops or rings extend to edge. Oh, so let me actually see something in here. This will work, but just in case I'm curious. So let's try something. Maybe I'm doing something wrong in here because I need to change this the group name to Sims. And now I can actually do, because we need to set this to Sims and Sims. And now, yeah, but it would work either way. We still have these extra points in here, but they are at the edges. It's okay. So we didn't even need this, but in this case, I'm gonna use it. Then we can do a group promote and promote the Sims to edges and do this. And now we can do a UV flatten, disable manual layout, and we get something like this. But if we input the Sims, we get this, and if we do rectify, we get a perfect result. This is what I'm looking for. So now we have the UVs flowing in the perfect direction that we can use to put there some noise and create the interior detail with cops. So we need to do the same in here, but I don't want to repeat this network. So we're going to create a compile block and place this. Let's just connect this for now. But this will throw an error because we are using a 0 input in here. I believe it's in here. So let's do add spare input, connect this in here and set it to -1. And now it works, but we don't want to connect it in here. So let's disconnect from here, organize this a bit, and do invoke block And let's make sure we name this, let's say mesh, and we connect it in here, clear all, add one, and input name will be mesh. Input path, I believe it's the compile end. So I'm clearly doing something wrong in here. So input path is not this, sorry. Let's see, no. Oh, we need the compiler in here, sorry. And now it's working. So now we have these UVs, and now let's do the for this one, and we have the UVs the same way. So we have this for the right and for the left one. Now we can simply merge these. Oh, and we need to merge over our initial geometry. So here. So let's get rid of these and create a merge with this one. Shift R. And let's see how this goes. All right, and now we can take simply an exploded view because we have a class attribute, I believe. So exploded view. Let's connect it to the side. Now let's do primitive and class. Oh, and it's the other way around. Why is that? Maybe we need to reverse in here. So let's do a reverse. Yeah, we needed a reverse in there. So now that we have all the UVs, why do I have a seam on there? So let me actually see this. Maybe I did something wrong in here. I don't understand why. So select the point. Oh, he's selecting other one in here. So let's do one. Yeah. And promote it. Oh, and now it's correct. Now we need to compute this all over again. So let's wait a second. Let's see how much does it take. Not so much. So now we should have decent UVs, as you can see. All right, guys, I think that's basically it. And now we're getting some issues in here. So let me pause and see where that's coming from. Okay, guys, it took me a while to figure it out, but basically, when we are doing this get bounding box center in here, it won't be perfect due to the nature of the deformation that we have in here. So what we can do is take as a third input this geometry, which is lining up perfectly, and use that as bounding box center. So let's see the difference. We get this, and if we do just the previous workflow, we will get some offset. So let's do 2 instead. And let's do the exploded view. And now as you can see, it's lining up much better. It's not perfect, but you know, if I find a perfect solution, I will let you know. But for now, we will have something like this. And as you can see, we haven't made much progress, but I hope you found this useful. It will take us a while to get to this final result, but hopefully you found this interesting, and as we approach the final result, we will get even more tips and tricks. So thank you. If you want to grab the files, feel free to do it on Patreon. And as always, thank you for watching, and I guess I'll see you next time. Thank you.